All right, here's kind of our final destination, being able to apply all that's been taught to you. Taught to you. So being able to do this and also explain what's going on. This is a very key idea of showing that you have understood all that we've done. So there's three things that could possibly be wrong. Wrong pattern. So should have been a double replacement, but it should have, or did a double replacement, but it should have been a combustion. So identifying, knowing what it should be based upon what's given to you as reactants. Wrong chemical formulas. You have some correct ones, incorrect ones. Putting the nonmetal first in a ionic equation, putting the least electronegative first, but in the idea that there shouldn't be this 2-to-1 ratio. Not having crossed the charges correctly. Having elements that should be monatomic, meaning just one atom, having more than one, or vice versa with the ones that should be diatomic and we've only got one. And then unbalanced or incorrectly balanced chemical equations, so wrong coefficients. All the things that we've taught you, you're going to have to be able to pick out and correct yourself. So let's start off with the first idea, the wrong pattern. We've got the different types, right? Elements making a compound, an element in a compound making new element in compound, two compounds making two new, and then the hydrocarbon and oxygen making CO2 and water. Remember, with the replacements, the replacements happen to like items. Positives will replace positive ions, negatives will replace negative ions, metals replace metals, nonmetals replace nonmetals. So you need to be well aware of these different parts, otherwise you won't be able to identify what's wrong with it, therefore not be able to correct it. Now, when it comes to chemical formulas, obviously super important. Otherwise, if you don't have the correct chemical formulas, you can't balance anything. Now, ionic compounds we deal with probably the most. Remember, they can use polyatomic ions, so be well aware of those. Positive ion, then the negative ion in the chemical formula, crossing those charges, and then making sure they're the lowest ratio when you make them that way. Combustion, so recognizing that hydrocarbon and oxygen, and if that is the case, the oxygen and hydrocarbon are going to be correct. Students last year tried to correct the hydrocarbon all the time by crossing charges and stuff. No. They can be many different ratios. I'll give you the right one because you wouldn't know better otherwise. But if you recognize it, CO2 and H2O are always the products, no exceptions. Most elements are monatomic, one-atomed, right? So if you see any of these type that should be one-atomed as two, that's wrong. But we do have our 7 diatomic elements. These all have to be this. When they're in elemental form, when these are bonded to other atoms, it all depends on crossing the charges. This is just when they're by themselves. So let's take a look at some examples and try to identify what's here first. So first thing we need to do is, do we have correct chemical formulas? So I'm going to go through, so maybe zoom in here, and look at my charges of what these should be. I'll place them over in green. +1, -1, 2 plus, 3 minus, 2 plus, 1 minus, 1 plus, 3 minus. So looking at crossing my charges, first off on the left side, I should be a 1-to-1 ratio. So that's NaCl. 2 and 3, I see I got the 3 crossed down for the calcium, but not for the phosphate. So Ca3, PO4, 2. When it comes to calcium and chlorine, that appears right. And for sodium phosphate, that also appears right. So obviously, I'm going to disregard any kind of coefficients that were there before because they were just blatantly wrong. So then I want to balance these here, get my 3 sodiums. I see I'm going to need 6 chlorine overall because I've got 2 and 3. So I'm going to need to put a 3 here to get my 6 chlorine, which means I'm going to need to change that to 6 to get its 6 chlorine, because now I have 6 sodium. Need 6 sodium over here, so that's a 2 to give me my 6. Now I've jumped around quite a bit, so let's look back. 6 sodium. 2 times 3 is 6 sodium. 6 times 1 is 6 chlorine. 3 times 2 is 6 chlorine. So I'm good with so far what I've done. 3 calcium, 3 calcium, 2 phosphate, 2 phosphate. So now this is balanced. So one part is doing the actual correction. The other part is writing it out. So what was wrong? So NaCl and calcium phosphate. If you want to use the names, you can. Each didn't cross charges. Correctly. And then those were the 2 errors, and then coefficients were wrong. Because, of course, they couldn't have been right if we had wrong chemical formulas. All right, let's take a look at our next one. Now I can see one thing that I've recognized is that I've got a hydrocarbon and oxygen. That means there's no crossing charges or anything. I have the wrong products. So let's start back at drawing. So my hydrocarbon's got to be correct. I can't correct it, but it should be O2. That's diatomic. H2O and CO2 are always our products. So now I'm just going to balance. I've got 3 carbon, 1 here. So 3 carbon for 3 carbon. 4 oxygen. I'm sorry. Undo. iPad thing's annoying. So I've got 8 hydrogen. I've only got 2 here. So in order to get 8, I need a 4 in front. Oxygen, I've got 4 oxygen here, 6 here, for a total of 10. So that means I need a 5 here. So what was wrong with this one? So first off, O2 is diatomic. And combustion is always CO2 and H2O. And coefficients were wrong due to that being the wrong chemical formulas. Now let's take a look at our last one. So I can see I have an element and a compound. So that means it's going to be single replacement. Now, like is going to replace like. And so if I think of my charges and whatnot, magnesium as an element has no charge. Calcium is a 2 plus. Nitrogen is a 3 minus. Magnesium in a compound is 2 plus, 3 minus. Calcium as a element has no charge. So first off, I know magnesium is not one of my diatomics, so it's just Mg. And then I've got my calcium nitride. That looks like it was correct. Magnesium and nitrogen, though, is not correct. So I see Mg3 and 2. And calcium is one of my monatomic friends. So I see my nitrogens are the same. I have 3 here. In order to get 3 here, I need a coefficient of 3. 2 nitrogen, 2 nitrogen, 3 magnesium, 3 magnesium. So looking back at what was wrong with this, coefficients wrong. It's always going to be the case. Almost always going to be the case, but that's why I want you to identify it. Let's see. Mg is monatomic. Monatomic. And what else was wrong? It was Mg and 3, or Mg3 and 2 had crossed charges wrong. And that's it. So not only do we correct it, we clearly identify with words what was incorrect about it, because that's part of it, I would say enunciating, not enunciating, it's sort of describing what was wrong to another reader. Coming with your questions, we're going to get a good amount of practice, and this will be part of your assessment. See you soon. Bye-bye.